Question 9, we have a wrecking ball that is coming in to the wall, and it's being used to demolish the wall. We're trying to calculate the change in gravitational potential energy first of all. We're going to need to recall an equation for this. It is the gravitational potential energy equation, of course. So GPE, we know, is equal to mgh. You might remember that from PE equals must go home. Okay, so we've got to figure out the change in potential energy. It's going to be mgh, so it's going to be a mass which is 400 kilograms. We're going to times it by g, which it says to take to be 10, and we times that by the height of 1.5. If you shove that into the calculator, it will tell you what the answer is. 400 times 10 times 1.5 is going to give you 6,000 joules. 6,000 joules. Now, it's worth mentioning at this stage, if you've got a copy of the mark scheme, you may have noticed a slight weirdness to it, otherwise known as an error. It says here, take G to be 10 newtons per kilogram. The mark scheme uses G as 9.8. Because sometimes people are silly. Now, it turns out in the GCSE, sometimes we use 10, sometimes we use 9.8. I think the book at one stage even uses 9.81. They're just different degrees of accuracy for the same number. The strength of gravity is 9.81, which is about 8. Sorry, not. Yeah. Let's try that again with words. It's 9.81, which is about 9.8, which is about 10. There is no official value on the scheme of work, in the textbook, in the exams, in the booklet, anything like that. So they will have to tell you which value you're going to use, and if they don't, then just use any of them. They can't penalise you for it. So we've figured out it's 6,000 joules for that one. If you use 9.8, it would give you 5,900 joules. If you use 9.81, I guess it gives you... no, it wouldn't give you that, would it? Ignore. Moving on. So 6,000 joules. Let's go with that. Nice and straightforward. mgh, multiply the three things together. Moving on to the next question. We have the heavy ball hitting the wall, and as a result, the ball and the wall and the surroundings all get a little bit warmer. The temperatures go up. Why is that? Well, because the energy is dissipated into the surroundings. In fact, if you said that, that would give you 2 marks straight away. 1 mark for saying the energy is dissipated, that means scattered or spread out, and 1 mark for saying where it's going into the surroundings. So the particles move faster, the kinetic energy of the particles is increased. All of these things are basically different ways of saying the same thing. Which of these things changes in both magnitude and direction? Nice question, this one. Well, first of all, if it's going to change in direction, it's going to have a direction. I can spot here energy, gravitational potential energy here, and I can spot kinetic energy. Both of those things are energies, obviously. Energies are scalars, but they don't have a direction, so they can't change in direction. So it can't be A or D, it's going to be B or C. Velocity and force are both vectors, so it could be either B or C, but the gravitational force is only ever going to be acting downwards. It's the velocity that's changing. As this thing swings round, the direction it's pointing in is going to change as it swings around, and also because it's speeding up, the magnitude of it is going to change as well. So it starts off maybe at the top of the swing, pointing in a certain direction. There it is. So as it starts to swing, it's going to have a small velocity in this direction. As it comes nearer to the wall, it's going to have a larger velocity in a different direction. So it's changing both magnitude and direction, which means it's got to be that one. So it's going to be velocity for that part of the question. Moving ourselves on. 6 marker here. So we've got to explain how the energy within the system changes during this time. So we've got a ball. The ball that you saw earlier is swinging backwards and forwards, and you can see the height of the ball is getting lower each time, or the maximum height that it reaches. So when it gets to this part here, it's got sort of, you can imagine it's kind of swinging this way. It's reached the bottom of its swing here. This is where it's released. So essentially what you're seeing is that it swings like this. It starts off with a big amplitude of swing, and eventually it kind of fades away. We're going to describe how the energy within the system changes during this time. So first of all, what kinds of energy have we got? Well, when it's nice and high, we've got gravitational potential energy. And when it's reached the bottom of its swing, it's moving really quickly, which means it's got kinetic energy. And it's basically going to be converting between those two forms of energy as it swings backwards and forwards. So we've got a varying gravitational potential energy. The gravitational potential energy is converted into kinetic energy as it swings lower. As it passes the bit at the bottom and starts moving upwards, it's going to be going back from kinetic energy, converting back into gravitational energy. You get your maximum gravitation up here, maximum kinetic energy down there, as we said, and the total amount of energy technically is going to be the same as time goes on. You're just converting between the two, although, as you can see, after a while that ceases to be the case, because as time goes on, the maximum distance that it swings, or the maximum height, is getting lower and lower as it slows down. You'll have seen pendulums or pendula before. They swing backwards and forwards, but eventually they come to a stop. That's what's happening there. The reason that they're doing that is because we're losing energy. So the energy isn't purely converted from gravitational energy into kinetic. Some is dissipated. It goes out into the surroundings. So you're you're heating the surroundings. You're transferring energy to things like the air, and then as a result, the size of the swings, or the amplitude of the swings, we could call it, is going to decrease as time goes on. So that is kind of a description of the whole process. You've got the written words there. You don't have to mention all these things. In fact, you'd be really struggling to get all those ideas in. You're just looking for a good explanation that covers enough of the relevant points. So these are the descriptors. For your 5 to 6 marks, you're deconstructing the scientific information, providing logical connections between scientific concepts throughout, balanced, well-developed argument that synthesises relevant understanding coherently, and the judgments are supported by evidence throughout. So if I was marking that, I'd be looking for you to mentioning sort of the key ideas and linking them together. Mention the gravitational energy, mention the kinetic energy, mention they're converted between the two, mention we're losing energy to the surroundings, which we can see because the amplitude of the swings is decreasing. That sort of thing will get you the 5 to 6 marks, and if you put in enough detail, you should be able to swing it into the 6 mark bracket. And that is question 9.